points verbally, but important points in a triangle. Important points in a triangle, which we very commonly use in coordinate geometry. Important points in a triangle. So the very first one is the centroid. Centroid of a triangle. How many people know what is a centroid? How is a centroid defined? Anybody? All right.
So the point of intersection of medians.
Very good. And what is a median? Who answered?
So
Who answered?
Mahita.
Very good, Mahita. What is a median? What is a median? A, B, C is a triangle. What is a median? It is a line joining opposite, you know,
Side
the
of the triangle.
vertex with the midpoint of the opposite side. Okay, this is a midpoint. This D is the midpoint of BC. E will be midpoint of CA, and F will be midpoint of AB. Okay, centroid of a triangle is a median. First I'll write median, the centroid of a triangle. Definition of median is median is a line joining vertex, a vertex to the midpoint of the opposite side. And centroid is the point of intersection of the medians. So let us see. I join AD, I join BE, and I join CF. Okay, this point will be the centroid G, centroid of a triangle. So centroid of a triangle is the point of intersection of the medians. Okay, now this is, how do you find? Now A is x1 comma y1, B is x2 comma y2, and C is x3 comma y3. All right, now D is the midpoint of BC, so it will be x2 plus x3 by 2 comma y2 plus y3 by 2. E will be midpoint of AC, so x1 plus x3 by 2 comma y1 plus y3 by 2, and F will be x2 x1 plus x2 by 2 and y1 plus y2 by 2. And now from the high school 10th class geometry, 9th and 10th class geometry, we know that the centroid divides the median in the ratio 2:1. This is 2 and this is 1, 2:1 ratio. Okay, the centroid divides in 2:1. So now you apply the point of trisection formula, the section formula for AD. D you will find out, D is this x2 plus x3 by 2, y2 plus y3 by 2. Now you apply the section formula. I leave this exercise to you. Okay, simple calculation. When you do that, you get the centroid G, coordinates of the centroid G, you will get as x1 plus x2 plus x3 by 3, comma y1 just all right, comma y1 plus y2 plus y3 by 3. Okay, this is the centroid. Got it? So this is a very important point in a triangle, centroid. Next, so centroid is point of intersection of the medians. Next, we'll go to circumcenter of a triangle. We'll represent the circumcenter as S of a triangle ABC formed by 3 points. What is a circumcenter? Anybody? Centroid is point of intersection of the medians. What is circumcenter?
So it's a point of intersection of perpendicular bisectors, sir.
Of sides. Very good. Very good. Circumcenter is the point of intersection of the perpendicular bisectors of sides. And it has some properties. So I'll just open another screen for you to explain this. Okay, so this is a graph. Now I'll so if you're able to see this graph properly, I'll take any triangle. I'll create a triangle. All right. Now this is a triangle ABC. 3 points I've chosen, 2, 3. B is 1, -1. C is 5, 1. Now what I'll do, I will draw perpendicular bisector. You see this? Perpendicular bisector. So I am taking perpendicular bisector of BC. What does it do? Perpendicular bisector divides. What is perpendicular bisector? It is a line which is perpendicular to the BC and it bisects BC. That means it cuts BC in equal halves and it is perpendicular. So this is the perpendicular bisector of BC. This is perpendicular bisector of AC. Okay, this line is dividing AC in equal parts, 2 equal parts, and it is perpendicular to AC. And I'll draw perpendicular bisector for AB. Okay, so you are seeing that perpendicular bisectors intersect at a single point. So this is the point of intersection of the perpendicular bisectors. So point of intersection of the perpendicular bisectors is called as the circumcenter. Now it is called why circumcenter? Because you can draw with D as this point as the center. You can draw a circle which passes through the three vertices. All right. So this is called as the circle. Going back to our blackboard. Okay. So this is a point of intersection of the perpendicular bisectors. Now, this circumcenter has properties. Right now, we are not speaking from straight lines point of view. We are speaking from point of view of distances. Now, we called this point as S, circumcenter. Now, this circumcenter S, because this is the center of this circle. This is the center of the circle. A, B, this circle is called as circumcircle, which circumscribes the triangle ABC. It passes through the vertices, and this is the center. Now center, so A lies on the circle, B lies on the circle, C lies on the circle, and distance of any point of the circle, distance of the center from any point on the circle will be equal. So SA will be equal to SB will be equal to SC. So from coordinate geometry, if A, B and C are given, you assume S as any point X, comma Y, and then write three equations. From this, we will get two equations, and you will get after simplification, you can find A and B. Okay, this is the circumcenter. This is very important. Circumcenter is equidistant to the vertices. Circumcenter is equidistant to the vertices. I request everybody to mute themselves. There is a disturbance. All right. Now, there is another formula. Right now, that formula is beyond the scope of derivation for you because you have not learned properties of triangle. But I am giving you for completion. Circumcenter, this is the formula. You note this down. Later, when we do properties of triangle, you will be able to solve this. You will be actually able to derive this. Right now, with the level of trigonometry that we know, we will not be able to solve this, but this is the formula for the circumcenter. x1 sine 2a plus x2 sine 2b plus x3 sine 2c by sine 2a plus sine 2b plus sine 2c. y1 sine 2a plus y2 sine 2b plus y3 sine 2c by sine 2a plus sine 2b plus sine 2c. This is the formula for the circumcenter. If you want, what are these A, B, C? These are angles. Let's go back to the triangle, or I'll draw, yeah, I'll show this. This is angle A. This is angle B. And this is angle C. All right. So if you look at the figure now, here you will be able to see now. So x1, y1 is coordinates of A. X2, y2 is coordinates of B. X3, y3 is coordinate of C. So x1 into sine of 2A, x2 into sine of 2b plus x3 into sine of 2c by sine 2a plus 2b sine 2b plus sine 2c. Similarly for y. However, without using this formula, you can find circumcenter using this result. SA equal to SB equal to SC. Okay, this is circumcenter. Very quickly, I'll cover incenter and then we'll stop. X center and X circles we'll do in the next class. So, it is incenter. Third one is incenter. What is incenter? What is incenter? Anybody? It is intersection, incenter of a triangle. Circumcenter is point of intersection of perpendicular bisectors. What is incenter?
Sir, the point of intersection of bisectors of internal angles.
Very good. Very good. It is I is the point of intersection of bisectors of internal angles. Okay, we'll just see this. Okay, we have now another fresh graph. Again, I will take a similar triangle as we have done last time. So this is a triangle ABC. Now you see this, the length of side BC, which is opposite to vertex A, is denoted by small a. The length of AC, which is opposite to B, is denoted by small b. The length of AB, which is opposite to vertex C, is denoted by small c. So opposite to vertex A, the side is small a. Opposite to vertex B, the side is small b. Opposite to vertex C, side is small c. Now I want to find the internal bisector. So this is the angle bisector I'm choosing. Now if I choose the angle CAB, so I get the bisector of internal angle. This has bisected the angle A in two equal halves. Okay, then again I choose the angular bisector. Now I'll choose for B, angle A B C. So this is the bisector of the internal angle for B. And then again I choose angle BCA. Now again you see the bisectors of internal angles intersect at a point. So this is the point of intersection. Okay. Now this is called as the incenter. And incenter has, very interestingly, with center at the incenter, you can draw a circle which touches all the sides of the triangle. This is called as the incircle. So this is called as the incircle. Okay. So interesting thing about incenter is the distance of point, the incenter from the sides AB, sides AB, BC and CA will be equal. Okay. So this is incenter. We are denoting the incenter by I. These are bisectors of angle. This will be a by 2 angle. This will be angle a by 2. This is b by 2 and b by 2. There are many properties, geometrical properties. We are studying coordinate geometry, right? So all the results of plane geometry come into picture here. So what is the coordinates of the incenter? The coordinates of the incenter is a x1 plus b x2 plus c x3 by a plus b plus c, and a y1 plus b y2 plus c y3 by a plus b plus c. These are the coordinates of the incenter. How do you do? How do you find the coordinates of the incenter? Again, it is a matter of using some concepts. The concept is, you can try this. The concept is the angular bisector of an internal angle divides the opposite side in the ratio of the adjacent sides. Okay, you can try this out. I'll use green pen here. So the internal bisector of angle A is dividing this side and this side in which ratio? Ratio of AB is to AC. So AB is C, C is to AC is B. So this point is divided in the ratio C is to B. Similarly, this line BC is divided in the ratio C is to B by this point. Likewise, you can do for the other points, and then take internal division of this. Again, you will get this result. This is the incenter.